Hello, and thank you for joining me. You're here with Data Science Teacher Brandyn, and we have a special project. This has been requested for a long time, and I apologize it's taken me so long to get to this. Well, I had finally some help with a great job with this workbook. Ula Usef helped with this workbook. You can say thank you to her on her LinkedIn right here. Thank you so much. I think she did a great job. She made some beautiful looking graphics or plotting to go along with the K-means clustering analysis, machine learning that we're going to do today. Okay, so let's follow along. This will be not the first time, but one of the first times I've done a project, one of the very few times I've done a project fill in the blanks of someone else's type project. So we'll see how good I do. Okay, so we're gonna get started by importing the libraries here, and we're gonna do pandas pd, matplotlib as plt, numpy as np, oops, what happened there? Seaborn as sns, and this one we're gonna do is we're gonna import warnings, and then what we're gonna do is warnings spell these things correctly. Warnings simple filter. Simple filter, and we're going to turn off spelling. It's just tough sometimes. Okay, so importing our libraries right here and turning off all the warnings. It's good when you have machine learning because not all of them, but most of them have kind of these warnings that they're usually still updating them, maybe changing some of the mathematics, and so they let you know that's going to be changing. And you can see that one time, but you don't need to see it every time you're running it. And it kind of makes your workbook look quite busy, so it's good to turn those off. Here we're going to do is we're going to do pd dot read csv, and we have the iris data set and a very classic data set. I really like these classic data sets. They're actually really good data sets, fun to play around with. And I just finished doing a whole bunch on the Titanic with deep learning, but here we're doing the iris data set, and we're just looking at the kind of the head of the data frame right here. So we look at the data frame, and you can see what happens is it truncates in the middle, and you kind of lose some valuable information. You not see some of the stuff that you need to. Sometimes it's actually good to look at all of it, but I like to look at the head, and I think Ula does as well. So you go dot head right here. If there's going to be problems in the data set, it's usually at the top or the bottom. So here we're going to look at the tail of the data set. And just make sure it looks, nothing really pops out of this thing, but it's kind of weird. Okay, so we can also look at the unique values. I'm curious about what the number of the classes are. So we look at the unique values that we have in this class. It doesn't give us the count, it gives us a unique value of the data sets, or sorry, of the categories in the class. So it can be useful. It's nice to have that access to that list and stuff like that. So it's nice to be able to make just that simple list. Okay, and as well see what they are. Okay, so let's look at the shape of the data frame right here, and we have 150 rows and 6 columns. So, okay, going into the .info, I would say this is really important to look at the data types. If you don't look at the data types, it will definitely just come back and bite you in the bum later on when you do this. It is really important just to understand what they are. If anything is kind of funny and looking like, it's not what it should be here, everything looks fine. We have integers for ID. We're not going to use that one today. And then when you have numeric columns, there's nothing. This is the problem. When you think it should be numeric and it's not numeric, it's an object or something, that means you have to fix it. So it's good just to check and see that you don't see those glaring errors. And here we see species. Just notice that it is an object because we saw that, and we knew that because we saw strings. That would be an object. Okay. Getting some quick information. This gives us a 5-point distribution here. So if we do df.distribution, you get the min, 25, 50, 75, and max. This plots. It's not as good as visualizing it, but it gives you kind of a brief idea of what the distribution is of any one of these plots and stuff. These all look fairly, not normal exactly, but there's no very strong. It looks like there's an outlier right here when you see the ID, but that's just the ID, I guess. But you can see here, I guess, right here in the petal length, there's a little bit of an outlier situation going on to the right. That's 4, 5, 6 for the 3/4, the quarter, half, half, quarter, and the end of the distribution. They're all kind of truncated, but then it really kind of tails off. That goes to 1.1. So it's a little bit of an abnormal distribution. So you can sort of get a sense of that and stuff. And that's something that can be done. Another good thing that you want to do is just, I really find you want to have access to this so much. Just check the column names to get the column names. So if you ever need a list of the column names, dot columns. Okay. Another good thing is to check it for the null values. Truthfully, it really is super duper important. So if we do dot df dot is null dot sum dot it is null parentheses dot sum parentheses, we can check. We see no null values. We also want to check for duplicated dot sum. Okay, we're to get an idea and sense of any of the rows are duplicated. This can happen a lot. It's a good check to do to make sure nothing funky is really going on in the data set. Okay, here we're going to do is get the count of each of the rows in the column, so dot count, and we're going to start our exploratory analysis. Okay, so here what we're going to do is we're going to go S and S, so we're going to assign this to an AX object, an access object, and what this really is can be any name you want to call it, but it's good if you stick with AX. Everyone uses AX, and I call it an access object because it's good to think of it like that, because what we're going to do is we're going to iterate through, we're going to call patches on top of this. What this is going to do is give us a list of all of the stuff inside of our plot, inside of our access, the place where plot is sitting, and we're going to be able to iterate through that then. So what we can do is we can pull it out, we can iterate through that, and what we're going to do is we're going to get the height of this, and we're going to know essentially where it is to put the count of the value of the height where it is. So we can see where the plot is. Going to get a nice count of the plot as well. This is a little bit more advanced, I would say, truthfully, but it's good to get kind of used to this to see this, because it should be really simple eventually, right? And so this is good, and you can do so much stuff with this as you kind of iterate through all of these things, pull out all of the shapes in your plot, and kind of do lots of fun editing and stuff to really add some nice texture to your plots. Okay, so heading into now, we're gonna look at the box plot of all of them, and we're gonna do them all together. Okay, so here what we're gonna do is we're gonna do SNS dot set PLT dot subplots and PLT dot subplots. Okay, for both of these, then what we're going to do is we're going to do think we just need this one time. I think we have this twice, and that's why we're doing two plots there. So let's just see what happens. I think most of the time, sometimes we have duplicated codes, honestly. The amount of times, but is I think that's why we're seeing this extra section in here. And so let's just see what this looks like. So we're just putting S and S dot box for all of these. And you see what's happening here is we're do the same thing twice essentially right there. We only need it once. So what we need to do is F and axes, and this is where all of the essentially quadrants are. So we're doing a 2x2 grid, and then we're going to put into the first grid the top left, top right, bottom left, bottom right into those places. So we only need this once, but we're going to call the box plot from Seaborn that we're then putting into the matplotlib axis, and that's important to understand because it's really good practice, because really what it is matplotlib is what makes Seaborn. Seaborn calls in matplotlib and makes all of it. So if we want to change some other things, the way that we would do this, and Seaborn is meant to work this way, we would just call matplotlib and access kind of the lower level functionality and make some of the higher, all the altering and stuff. And this is why Seaborn just goes right into the matplotlib object like this. So they're meant to work together. So it's kind of different thing, but it's good to kind of get used to playing with libraries and mixing and matching them, because that's really one of the many things that you can do with code that you cannot do with your mouse and your computer. Excel has to be able to do everything. With this, really you're able to take this function from Excel, mix it with this other function from Google Sheets, if they didn't have all exactly the same stuff, and then you can do some kind of funky stuff with that. And this is really kind of one of the many powerful things that you can do with coding, with Python, coding in general, if versus with a mouse in the way that you interact with the computer. Okay. So here we're going to do in the next one, we're going to do sns.displot. We're going to call this from our data frame, and we're going to plot the pedal with centimeter, and then we're going to do plt.figure right after this. So again, we're mixing the two libraries, but they are the same library at the end of the day. You do have to spell cblock correctly. SNS. Yeah. And then, or put the alias in correctly. Okay. So we're going to do, okay. So we've done the disk plot now of the, sort of the disk plot of the pedal width. Now let's do the SNS dot disks plot here. Okay. The next one, then we're going to do this. Keep inspecting, just mixing this up right here. We're going to do SNS dot disk plot, and then from the data frame, we're giving this, just notice, we're giving it one column here. KD equals true, bins equals 30. Histogram, we don't want to see histogram here. We just want to look at the outline of the distribution, get a good sense of the shape of it, really, and that's kind of the value of this. I like this, using this SNS dot disk plot, so DIS plot without the T. Okay? So there's two different plots in Seaborn. Get a nice, I mean, the same type of plot, but you get a nice feel here, and really what we're doing here is doing hue equals species. So change the color of the species by the hue, and you can see that they're really pretty distinct. This should be a fairly easy clustering problem. This is why it's a linear one, because it's a fairly easy clustering problem. But you can see here there's really good separation. This one not so much. The sepal width centimeter does not actually seem to show as good of a separation, maybe for the ear, iris, setosa, but the rest of the other two not so much. The versicolor and the I don't even know what I'm trying to pronounce this. If I can stop that. And here we're doing one last time sns dot dis plot. Oops. Do that correctly. There we go. Dis plot. Oh, and what we have to do here as well, we have to do data. I didn't see this one. Making sure I'm paying attention, which is good. Data equals df right here, and that's a really important thing in Seaborn. You have to give the whole data frame access. Seaborn, give your data frame, give Seaborn access to your data frame, and then you can just call the column titles like this, and it's a little bit easier to write, a little bit quicker and cleaner, especially when you're doing a lot of different options. Here we're doing again sns dot disk plot and data equals df. And then the next one here, we're going to go sns dot pair plot. I'm not going to write this. It's going to take a little while. Pair plot palette. I like the kind of palette color that we've used today. A little bit more of the palette pastel color and stuff. It's really quite nice. Here we're going to go df.core and get a correlation matrix. And we're going to assign that to correlation. Get a correlation matrix. It's pretty, you can inspect this, but it's pretty hard to see. So really, what a good thing is to use the Seaborn heat map to put a little bit more color to this, so you don't really have to look and analyze and search for these numbers so much. So what we're going to do here, we're going to go with Seaborn axis style. We're going to set to a dark grid. We're going to plot subplots. We're going to add a title. We're going to go plt.title. And we're going to go sns.heat. So I actually want to see, let's see if this works. So I just like, one thing I like to do, not to judge less work or anything like that. One thing I like to do is add this line width argument. So that's a little bit of white space in between these grids. I honestly, it's such a little detail, but I find it really looks quite nice. So just LW equals 2. And so really nothing special. We're just putting a heat map with a title, and we're doing a dark grid. So just making a little bit more, changing the style slightly. It's not a huge one, but changing the style a little bit just to show a different way to play around with this. Okay. So what we're going to do, we're going to make X and Y of our features. We're not going to play around with as much of Y, but we're going to play around with our X. really see our clustering and see if we can make similar clusters to what we had in our data frame. And oh, I need to fit the model. I need to put some code in here. uh, oh, fit. Oh, duh, I need to put the data. Oof, I do know what I'm doing, I promise. So we fit the data right here, and this is a really handy plot. It's pretty easy to find the elbow. It's probably one of the easiest visual inspections to do, but this is nice to have as confirmation, you are seeing what you're seeing right here. And this is just showing the time too. So I wouldn't worry about this so much. It's showing the time to be able to do this, to do each one of these. Okay. So really we're considering with the blue line, we're seeing this and we see really 3 is what you see really where it starts to crank, where it starts to bend like the elbow up a little bit. Okay. So what we're going to do then is we're going to go fit the model. We're going to do Kmeans. And we're going to fit the model. We're going to do 3 clusters because that's what we found right here. We're going to do max iter. And these are just setting up some of the parameters so it doesn't kind of go on too long, I guess I would say. And we'll set the random state. So the random state so that it happens the same every time. That's important when you're doing something to show people. It helps them. So what we're going to do is we're going to go model.kmeans, and what we're going to do is we're going to do predict, or sorry, fit underscore predict, because we don't really need the model again, we just need the answers from the x values, right? So it would change if we didn't set this random state, it would change every time, so it's nice to have this set. Now we can see very, very distinct clusters, it's obviously in order and stuff like that. So what we can do next is go PLT, or let's actually do SNS, we should do SNS scatter. So SNS.scatter, putting in the model, the X and the Y right here from clusters, really the points of the clusters, the centroids. And then we're doing S equals 100, yellow. I'm going to change this to orange. And not to be cheesy, but I just huge fan. Yellow. It's just not my color. Silly. S and S. So this, I think this is PLT. So PLT. Scan. Okay. So here we got our nice little dots in the middle right here, and our label centroid, so we can see that this is going to show up in our legend as centroids, and then PLT. Let's add some stuff to this. Let's do PLT.scatter. Let's look at one of our clusters right here, and we're just doing logical indexing. When one value is equal to 0 and one value is equal to 0, we're going to do this, and then select one of them. So X and 1 and the other. So we can see in the 2 dimensions, selecting one column and then the other column, so we can see only in 2 dimensions, so we can plot. So we're not looking at all dimensions. Okay. So looking at plt.scatter here for the next one as well, for the one in blue. Now we're going to do the scatter here. Oops, not capital letters. Okay. Here, and we're going to call this the Versi color. And we're putting the label here. We're not doing the plt.legend, but we'll do that at the end. Okay, so plt dot okay, so there we go. plt.sky. Okay, doing that one. And plt.scatter right here. So we're going to add all those lines together. And I agree with doing it like this. You do pieces and you put all those pieces together. People don't, well, maybe they do, but maybe when you're 20 years of experience, a lot more experience than I have. You would write it all at once, but it honestly is a lot easier just to write piece of your code, make sure each piece of your code works, build your bigger thing, and then put it together in a function or something like that, or just in one block of code. But you might see the final product, you might not see how someone built that, but that is really how people build things most of the time, because it is, you just want to make sure every piece is working, because if you don't, it's hard sometimes to find out which specific piece is causing the problems, right? And then kind of understanding specifically what goes into and out of functions can also be very important. So seeing the output of each of the functions can help you make sure you're connecting the pieces every line of your code correctly. Okay. And that's really one of the things that, I mean, I even say ChatGPT is very good, but it struggles with sometimes is the, and that's really where we have to pay attention, is the connecting the lines of the code, what comes into and out of functions can be very subtle why things won't work. And so we always have to pay attention to that. So that's why, again, another good reason to do it piece by piece and just make sure you're doing it yourself. Okay. So we did the three plots. We did then do the centroids. I set it to 400. So they're going to be big circles or big stars. Here we're going to do stars orange colored. And we're going to do PLT dot legend, PLT dot grid, PLT type layout is a good one because it makes sure that everything just kind of fits nicely. It doesn't necessarily make it tight, but it just reorganizes when you're adding all these plots together. And sometimes it just does, it gets disorganized and stuff like that. They don't sit perfectly, so just kind of make sure everything sits nicely. And then doing PLT.show. Okay, and there we go. And then we got our clusters right there. So it's really quite nice, beautiful looking plot right here. There stars right in the middle. And this is a very easy cluster. So these are where our model found the centroids of our clusters was found at the same place. And this is if we chose 3. If we chose more, and that would be something good to play around with. Where would four clusters sit, right? So that's one of the things is you can cause 4, but would that make sense here, right? And maybe you put one up here, you put one down here, you put one over here, but is that really capturing the truth of the data? The colors are based on the species and stuff, and these species are very distinct. You won't find these clusters to be distinct like this in many other data sets. Okay, so here what we're going to do, we're going to do a silhouette score. So we're going to give this x, and we're going to predict on x as well. The silhouette score right there, 58. I mean, I wouldn't call that great. I believe you want to get this closer to 1. Okay, and you can see she explains how this works right here as well. So the silhouette score and mean clustering is 1, shows how well the data point is clustered. 0, RC is good. Okay, above 0 seems good. So we apparently have a good score. So that's good. I have seen these where they are quite small, so that makes sense. Okay, and honestly, I don't do clustering that much, so why it's taken so long to get around to this project. So I really appreciate Lula again for your help on this. Okay, so silhouette visualizer, we're going to put in our X value right here. We're going to go visualizer. This is the way, this is the syntax for working with Yellowbrick. You create a visualizer, apply to it, then you fit it to it, and then you go visualizer.show. Okay, so similar to Matplotlib, but it's not exactly the same. Oops, sorry, and it's not X right here. It's the model. So we're going to fit it to the X. So we give it the model and then we have to fit it, right? So that makes sense, right? That we give it the model first and then fit it. So, okay. So, and then we're done our project. We got our silhouette scores, we got everything, and we can see we do have good separation here. This is really what the ideal situation is. This one, you really want to see that this stays above this line for as long as possible. This you can see that this one has the least distinct cluster because it kind of separates very, very, very quickly. It kind of drops off, sorry, very, very quickly right here. This is just saying that this cluster stays closer together for longer. And then this is showing for every row how much farther away it gets from the other ones, essentially, in a very simple way to put that. Okay. So thank you very much for joining me today, and I will see you next time.